Let's begin. My name is Vladimir Alyamkin, and I am Deputy Studio Director of Pushkin Studio, MY.GAMES. And today we will speak a bit about networking on Unreal Engine. So, first of all, we will make a small jump into the history, because if we want to learn something, it's better to know about where is the beginning. So, the first step of Unreal Engine as a great engine for multiplayer games was release of Unreal Engine Tournament at 20th century. Okay, I remember these days. I had a strange box beeping and doing some crazy noise while connecting called modem. It's time. Okay, mother, please don't call your friends. I'm playing. It's important. Okay, it will mad times. But this box has speed of 33 or 56 kilobits per second, and you heard it right, kilobits, not kilobytes. But I played Unreal Tournament. Of course, we had LAN battles, we have different championships in our town computer clubs, but 10 players simultaneously in one battle with modem. I think it was great. Second step, 2018, release of Replication Graph. It was Unreal Engine 4.20 version, when we've got the technology called Replication Graph. The idea was simple. We have a large map. Let's draw a grid on it, divide it, split it into the cells, and each cell became a replication node. So, if you are staying in this node, you replicate only nodes nearest to you, and do not sync, do not replicate any data outside this node, outside your nearest neighborhood cells. So, why? We've got Replication Graph because we've got player-unknown Battlegrounds game, and now every startup, every indie developer wants to do its own PUBG. Also, as you know, Epic Games had Fortnite. Did you count that? First step was at 20th century. The second step was 2018. So let's count it together. We have 19 years and nothing happens. Nothing significantly changed in Unreal Engine in its networking part. So let's think about it. Why? Why it's is it was born ideal? Maybe lots of games made with Unreal Engine through the almost 20 years. Hundreds of them, maybe thousands of them, and it just works. Just worked. Maybe it's time-proofed, maybe it's good, maybe I should go outside and say, okay, it's closed, but no. First of all, let's think about it. Multiplayer games are mostly based on UDP protocol. No TCP protocol used. So we are just we are using UDP. We are just flooding all the network with our data. We are sending and sending and sending, and it works. Okay, go next. Flooding is good. Epics are great game developers. They created a technology which we can say right now that really time-proof, because we have Unreal Engine 5 right now, and a lot of time ago. It was a lot of time when the first Unreal Engine was released. Also, with Unreal Engine, you can develop mostly games that uses authoritative client-server model. So you have client, you have server that simulates the same logic and controls which data to sync with clients. So this whole image looks good, it works, but I really like this screenshot. It's my favorite about networking on Unreal Engine. We have 2020 year, end of it, December. Also, we have release of 26 version of Unreal Engine 4. And in this release, we can find this Git div. So we had something called max client rate at 15K, and now we have max client rate 100K. It's big changes. Why? What's about it? So now and then, the story of 20 years of development is to change the 2.5K to 100K. What is it? What this means? This means that Unreal Engine on its initial release has the same system that uses right now, and it emulates and assumes that client rate is about 3 kilobytes in 99th and about 100 kilobytes at our days. So it was step by step increasing of these values. I'm really surprised that only in 2020 they made these goals, because all games developed before uses this approach already. But right now, with the release of 26 version, you can develop your own game with modern weapons movement on Unreal Engine without tweaking network settings. So, by the way, why we have this limit? Why not to set it to the infinity and using something like network configuration of max client rate? Okay, I have one gigabyte speed of 1 gigabit speed internet at home. Why should I limit it with 100K? I don't know. It's because of using some kind of technology called reliable procedure call, RPCs. But I will talk about it later. So, next step. The third step, it's 2021. Epic Games offered us to use a push model. What is a push model in networking terms? How replication works? You have lots of properties that need to be synced between server and clients. And all these properties can be synced or desynced at the moment. So, some black box called Unreal Replication decides how to sync them and how to sync them, how and when to sync them. So, it uses a lot of CPU resources because there are a lot of properties, and the system doesn't know nothing about when they were changed. So, Epic said, okay, now we have no automatic synchronization mechanism. Now we will replicate properties only when you changed them, but even not changed when you marked it dirty. So it's something like replication on demand. It's really less CPU intensive, because now we have no obligatory checks about state of replicated properties. The first step and final step for now is the new system in Unreal Engine 5 that's called Iris. I don't know exactly is it called for a part of the eye or for a plant, so I used both pictures. It's great system. Work on mistakes were done. So now we have a combination of previous works. Because what is Iris? Iris is a push model combined with replication graph. It has a different mechanism called not nodes. I don't remember how, but the same ideas that used in replication graph. And modern new filtering system instead of previous relevancy system. So, we have one little minus of this technology. It's backward compatibility with previous replication system. Why it is a minus? Why it is a cons of this technology? if you are developing something new, it's better not to be connected to the past technologies, because only with new approaches you can break the rules and add something really new. Today they can't do it, so they just use previous approaches, but in new modern form. I think it's not so good as epics could do. But also, we have one mostly interested for me system, filtering system. Why? Because why is that? Because when we are using remote procedure calling called the RPCs, we have to choose how to sync these functions called between client and server, and we have only two options. First, we can call from one client to one server, or backwards from server to client, or you can call function that will be called on all clients. So if you have 100 players, you can call multicast RPC, you have a lot of data to be transferred. Sometimes, I think every time, we don't want to do it. So now we can choose how to sync and to whom to sync. I don't know why I'm using computer still. So let's check the whole picture again. We had a replication in 20th century, we have a replication graph in 2019 or 2018, then Posh model and Iris. It's really interesting that it's still not solved the issue of Unreal Engine, is how to create the really big worlds. For example, I want to have my own EVE Online, or something like Lineage Second. I want to have 1,000 players at the same time, at the same location, speaking with each other, fighting each other, and etc. But nowadays, I can't do it. It's still not solved. You have one dedicated server that handles only one world, and it mostly limited with only one core of your hardware. You can't split it into lots of cores of your processor and calculate it on it. So it's interesting, but nowadays you have to develop something on your own, use a special OS and something like that. I want to have this feature from the box. Epics, please do it. Okay, but today we are gathering to listen about problems, what we are doing wrong. I described a model that works for a lot of years, and it's okay. First of all, let's return to the netcode. What is a netcode itself? It can be split into three parts. First of all, it's the way how to sync. It's a tech layer. It's really how technically we are syncing data between server and clients. What protocol we are using, how we store this data, how we connect it, it's a big question. The second one is what to sync. It's a gameplay-related logic layer. So, for example, if you are making shooter, you need to sync locations, speeds, movement itself, how player shoots, and every hit that player made on another player. For example, if you are doing some multiplayer cars, you need to sync their physics. The third one is how to trick a player, and it's also a great and big question about interpolation, extrapolation, network prediction. It's about how it feels playing online with network lags, with network errors, with big ping, etc., etc. So, but today we are mostly talking only about the first one, how to sync, how technically sync it, because we are using Unreal Engine, engine for a lot of games, for a lot of genres, and we can make different games. We don't want to be related for gameplay right now. So we have an epic way. An epic way is to use the replication system as it exists in the engine. So you just have set of properties, you mark them as replicated properties, and you get a game and a state that sync between client and servers. It's okay, it's fast, it's very convenient, it's very clear how to use it. I want health to be synced. I mark health as a replicated property. I want to sync my fire that I'm doing. I have to use remote commands called RPCs or remote procedure calls. So mostly they work together, RPCs and replication property. Okay, but few interesting questions. I made a game, I mark my properties, my character moves, my character fires, and all seem to be okay. For my prototype, of course, it's great, really great. I spent 5 minutes and it's multiplayer game, it's not single now, and I'm cool. Okay, but how you can track that client is synced? How you can track that all the data you need on a client you have? How you can track the progress of replication? For example, I'm a new player, I'm connected to the server. I have a lot of data to download first. It's gameplay data. It's sometimes it may be an array of objects distracted on the level. So it has its size. So, but how I can make it? Okay, next question. How I can check that I am particular game client is desynced? How I can say that, okay, I'm desynced, I need to force replicate my state, please, server, give me this data. And the answer is easy, you can't. You can't do it with replication. Standard replication built in Unreal Engine has lack of control. It's just really leap of faith. You're marking properties and it works. Good for prototype, not good for production. The second part of epic way is avoid RPCs. As I said before, they work together in tandem with property replication. But if you used RPC on Unreal Engine, especially reliable one, I think you know what I'm talking about. The reliable buffer overflow hell. It's a situation when Unreal Engine says to you, reliable buffer overflown, and disconnects client. It's really not cool to be a player which will be disconnected during the battle. I just want to play. I just want the game to do all its magic. I don't want to be disconnected. Why I'm disconnected while I'm firing to my enemy? I don't want. I will delete this game and never return. So it's not good for player. But it's epic way. Please do not use reliable RPCs. Please, RPCs are expensive. Okay, we're saying it in documentation, in lessons, at forums, etc. And also, we can even say that reliable RPCs it's something like using of TPC protocol in your game, and TPC are bad. Please do not use TPC for multiplayer games. Stack Overflow proved. Okay. Also, before Iris, we can't control direction of RPCs, and sometimes we have to use multicast RPCs that send data to all clients, and it was very expensive too. Okay. I really like this screenshot too. It's about reliable buffer size. It's 256. And it was committed to Unreal Engine 8 years ago. It's about 9 years ago for today, because Unreal Engine 4 was released on GitHub almost 9 years ago. So, what we have? We have a pack of variables and their values that was applied to Unreal Engine on release. We just had dive deep to history, and maybe this reliable buffer not changed from the Unreal Engine 1. It was the same in Unreal Engine 3, by the way. So we are using sizes of different buffers we are sending our network from the past. It's something like I have a mobile phone with a 5G connection that has unlimited bandwidth. I don't know, and I have to use reliable buffer with this size for all those years. Maybe it should be larger. Why? Why we had these variables? Why we had these numbers? I don't know. I really don't know. I have no explanation of this behavior. But what if I say that RPCs are really our friends, that RPCs are our servers? With remote function calling, you are controlling the state. You choose how to change the state. You choose when to control to change the state. You are not relying on some black box changing your variables on different clients different ways. Now, you and only you controls the data transactions between client and servers. Also, and you can check it with Valorant case. Riot Games are great guys, and big thanks for them for sharing this information in public. If you are using RPC instead of property replication, you will get significant boost at performance. And it's very important for calculating expenses on dedicated servers. Of course, we have minuses. Now you have to control by yourself. Now you can't just mark the properties and say, okay, it worked. So you have to write your own code. But it's a minus and a plus simultaneously. Iris is recommended for filtering, of course, because with proper filtering, you have more control, you have more optimization on data size. By the way, about data size, today we have 2023. Even YouTube video with medium quality requires bandwidth about 2 and 5 megabits. And of course, I'm saying not megabytes, megabits. So it's about 500 kilobytes per second. And our limit in Unreal Engine is 100 kilobytes. So YouTube video is more heavy than our game by default. Also, as you can say, you are trying to use RPC, you have to use reliable RPC. Reliable RPC is something like TCP, but on UDP layer, it has the same issues. For example, with packet losses, 15% or 20%, it will be unplayable. But no, reliable RPCs on UDP will work like a quick protocol. And it's modern web protocol, which introducing right now towards the world, and it's just magic. You will save a lot of CPU resources and network resources. So it's modern web, reliable function calling via UDP. Okay, it's about end. So what's the secret of success? How to create an optimized multiplayer game? First of all, you need a game state that will be clear to be synced. So you need to know what is your game state, what properties you are replicating, what properties you are syncing between clients and server. It's not something like mark them all and then just hope that it works. No, you should know what you're thinking. You should know it exactly. But if you have a state to be synced, it's great that it will be changed only at the clear points. If you are changing your game state in a lot of places, for example, weapon can change your bullets, heat can change your health. I don't know, maybe a tree can change your health. So a tree on the map, it's okay, it's something like pickup. But if you are not controlling it, you will be out of control. So it's great that you change your state by transaction. For example, transaction, change health. It's the entry point of changing this state. The third point, you have nice packaging and serialization mechanism. For example, you have state, it has some size. You need to sync it between server and client. So you need to pack it to do it right. Thanks God we have F4A in Unreal Engine, so this one is solved. Just use Unreal Engine. It has even quantized vectors, etc., etc. So it's solved. You don't need to write it on your own. RPCs are friends of transaction. Just use them to call a transaction with parameters. And if you are using reliable RPCs, you have control over the order of changing this state. So if your transactions are deterministic, you have deterministic transaction, so you have deterministic state, so you have also deterministic order of changes. It will give you ability to make the most optimized network game on Unreal Engine. And as a conclusion, don't afraid to use RPCs. Really, don't trust epics on this. Don't trust forums on this. RPCs are great just because they configured at the 20th centuries. It's not means that they are bad. Epic way of doing games on Unreal Engine, all their approaches are best for Fortnite. They are not about all games you able to create. So you shouldn't trust them blindly. You should do your own experiments. You should try different approaches and find the answer for your game by yourself. Also, we have open source product, which we use in our studio for almost 7 years, I think. And it's about state, it's about transactions, etc., etc. If you want to know more, let's check.